Hello everyone. In this section, I'm going to discuss another important topic: implement and verify network policies for restricting pod-to-pod communication. Kubernetes networking allows seamless communication between pods, but unrestricted pod-to-pod communication can lead to security vulnerabilities. By default, Kubernetes permits all pods within a cluster to communicate, which may not be ideal for security sensitive applications. So by default, one pod can communicate to another pod in a Kubernetes cluster. So this is the default behavior. So what are the disadvantages for that? So let me take an example. Suppose you have a banking application deployed in Kubernetes cluster with two servers. You have created one pod that is for front end, which handles user interactions and display account informations. You have created another pod that is for database, which stores sensitive financial data like account details, transaction, etc. Now by default, Kubernetes allowing all pods within a cluster to communicate to each other. So if the front end pod can directly talk to the database pod, it means any other pod in the cluster can also potentially access the database. If a hacker gains control over a vulnerable pod, for example, due to security flaw in another application, they could directly query database and steal sensitive information. So this is one of the major drawback for direct pod-to-pod communication. So the solution is you have to use the network policies. Network policies provide a way to control and restrict pod communication based on predefined rules. In this presentation, we will explore how to implement and verify these policies to enhance Kubernetes security and ensure proper access control. Now moving to the next PPT. So here, this is the first image, pod-to-pod communication is allowed. So in this scenario, you can see pod, which is demo1, which is running in dev1 namespace, can communicate with pod demo2 in dev2 namespace, and the dash line with a check mark indicates that network communication is allowed. So by default, Kubernetes allows all pods within a cluster to communicate unless a network policy is applied to restrict it. We have another image that is pod-to-pod communication restricted. So here a network policy is introduced between dev1 and dev2. Dev1 and dev2 is the name of the namespace. The red cross mark and the network policy block indicate that communication from pod demo1 in dev1 to pod demo2 in dev2 is restricted. This means a network policy has been enforced to prevent traffic from dev1 to dev2, ensuring security and isolation between namespaces. So what is the key takeaways? Without a network policy, unrestricted pod communication. With a network policy, control restricted communication for better security and isolation.